You know, it's kind of funny. We use our phones and computers every single day, right? We tap, we click, and things just happen. But underneath that super simple surface, there is an absolute storm of activity. And it's all being managed by one single piece of software that's more important than all the others combined. So today we're going to pull back the curtain on that unseen conductor, the operating system. Let's find out what it actually does.
To really get why an operating system is so critical, we first have to understand the problem it was built to solve. And that problem is the raw, chaotic, and kind of dumb power of your computer's hardware.
Seriously, think about it for a second. You click an icon and an app just opens. It feels like magic, right? But in that tiny split second, your computer has to manage a dizzying symphony of signals and requests. If even one of those notes is off, the whole thing grinds to a halt.
And that's because your computer isn't really one thing. It's more like a team of brilliant specialists that, on their own, have absolutely no clue how to talk to each other. They're like an orchestra full of virtuoso musicians, but with no sheet music and no conductor. Just chaos.
So let's meet the band. You've got the CPU, that's the brain, doing all the heavy thinking. You've got memory, which is like its short-term scratch pad. Storage is the long-term library for all your files. And then you have all your I/O devices, the keyboard, the mouse, the screen, that let you actually interact with it. Each part is a genius in its own right, but they all speak totally different languages.
And here's the wild part. This coordination problem is getting harder all the time. Thanks to what's called Moore's Law, the power and complexity of all this hardware has been exploding for decades. We're talking billions of moving parts that all need to be managed perfectly. It's a staggering challenge.
So how do you turn this pile of powerful but disconnected hardware into a machine that actually works? Well, you hire a conductor. And in the world of computers, that conductor is the operating system.
So what is an OS, really? At its heart, it's the master translator. It's the essential go-between that stands between you, the user, and all that raw hardware. It's the bridge that turns your simple clicks and tabs into commands the hardware can actually understand and execute.
You know, I love this analogy. Think about it. A government doesn't build the houses or write the books itself. It creates the roads, the laws, the infrastructure, the environment that lets everybody else do their work productively, while the OS does the exact same thing for all the software on your computer.
So if you look at the whole system, you've really got these four layers. Right at the bottom is the hardware. Sitting directly on top of that is the operating system. It's that foundational layer that lets all your other apps, your web browser, your games, everything run smoothly for you, the user, at the very top.
Okay, so what does this conductor actually do all day? Well, its massive list of responsibilities really boils down to two main jobs. Two critical roles that it's juggling every single millisecond your computer is turned on.
You can think of the OS as having two different hats. With one hat on, it's the resource allocator, deciding who gets to use what and when. With the other hat on, it's the control program, acting like a strict referee to make sure every app plays by the rules and doesn't cause trouble for anyone else.
As the resource allocator, the OS is basically a traffic cop in the middle of the world's busiest intersection. You've got all these different programs demanding to use the CPU or needing to access the hard drive, all at the same time. The OS steps in, directs the flow of traffic, and makes sure everything gets where it needs to go without causing a total gridlock.
And as the control program, it's all about safety and stability. The OS puts up walls between programs, making sure a bug in one app can't reach over and steal memory from another app, or worse, crash the entire system. It creates a safe little sandbox for every program to run in.
So let's dive a little deeper into that first job, resource management, because this is where the OS does some of its most incredible and honestly, invisible work.
The OS is constantly juggling four main resources. It manages who gets to use the CPU's attention through process management. It carves up your computer's RAM using memory management. It organizes every single file on your hard drive with file management, and it handles every single thing you plug in through I/O management. Let's break those down.
First, process management. Now, a process is just a fancy word for any program that's currently running. The thing is, even if you only have one CPU, the OS is so fast that it switches between all your open programs thousands of times per second, giving each one a tiny slice of attention. That's what creates the illusion of multitasking, letting you watch a video while your email updates in the background.
Next up, memory management. Your computer's RAM is like a workbench with very limited space. The OS is the master organizer. It gives every running program its own little spot on the bench.
And the moment you close an app, the OS is right there, meticulously cleaning up that space to make sure not a single byte is wasted, getting it ready for the next task.
Then you've got file management. See, your hard drive is really just a gigantic, unorganized warehouse of data. When you click Save, you're just telling the OS, hey, hold on to this for me. The OS then finds an empty shelf, stores your file, and makes a note of exactly where it put it so you can find it instantly later. It handles all that complexity so all you see are nice, neat folders and files. And finally, there's I/O management. That's the OS making sure that when you move your mouse, the cursor on the screen actually moves.
Okay, so we've gotten into some of the nitty-gritty details, but how does all this technical stuff actually translate into the smooth experience you have every day? Let's connect the dots.
This is where it all clicks. Let's say you open a super simple paint program. The moment you click the icon, the OS creates a new process and finds space in memory for it. You draw a line. That's the OS managing the input from your mouse and giving the app's CPU time to actually render the pixels on screen. You save the file. That's the OS handling file management and writing the data to your hard drive. Every single action is being orchestrated by the OS.
When you boil it all down, that's what the operating system is. It's the ultimate invisible engine. It takes our simple human intentions, a click, a swipe, a key press, and translates them into the billions of precise electronic operations needed to make them happen. It does all the hard work so that for us, using a computer feels effortless.
The OS is the foundation of our entire digital world, evolving from clunky command lines to the beautiful, intuitive interfaces we carry in our pockets. It truly is the unsung hero. But with things like AI, quantum computing, and the Internet of Things adding brand new layers of complexity, the real question is, what will the operating system of tomorrow even look like?